Okay, so this is chapter 1, day 2, order of operations. And the example I have here at the top shows you why it's so important to know order of operations. So this little math phrase, when Tommy does it, Tommy gets 49. When Benny does it, he gets 81. You can see how if we don't have a agreed upon order to do the math steps, you can get completely different numbers, and that would cause huge problems in finance, in construction, in a lot of stuff. So we're going to come back to that. So Roman numeral 1, order of operations. Now, a lot of you learned this in middle school using the acronym PEMDAS, which is not a horrible acronym, but it leads to some misunderstandings that will cause issues for you this year. So we need to talk about how you need to adjust your understanding of PEMDAS so it's more accurate. So the first step in order of operations is what we call grouping symbols. And in PEMDAS, the P stands for parentheses. That's not completely wrong. Parentheses are grouping symbols. But here's where it kind of falls short. Brackets are grouping symbols. Absolute value bars are grouping symbols. Even a fraction bar is a grouping symbol. So any grouping symbols, you start with them first. You start inside the grouping symbols and work your way out. If there's one pair of grouping symbols nested inside another, you do the inside pair first and then work your way out. All right, number 2, this one actually works with PEMDAS. The second step is exponents. And sure enough, in PEMDAS, you have an E for exponents. Exponents do not have to be left to right, but I will tell you if you do them left to right, you will never be wrong. So that one has a little bit of flexibility. Now we get into where PEMDAS really is not very accurate. The third step in order of operations is multiply and divide. Now in PEMDAS, it makes it look like you multiply everything first, start over, and then you divide everything second, and that is not true. Not at all. The multiply and divide step, it's the same step. You go left to right, and you do whatever you hit first. So you might multiply, divide, divide, multiply. It just depends on whatever you hit first. So multiply and divide are on the same step. The last step is the add and subtract step. And again, PEMDAS is misleading because it makes it look like add and subtract are different. They are not. They are the same step. You just go left to right and you hit whatever you hit first. So it could be add, subtract, add, subtract. It's whatever you hit going left to right. So PEMDAS isn't terrible, but you have to understand it. It's not entirely true. All right, Roman numeral 2, let's do some practice. We're going to start with 7 times 4 plus 7 times 3. So in your head, you're going to want to say, are there any grouping symbols? No. Are there any exponents? No. Multiply, divide, yes, you start from left to right. So you do that one first. 7 times 4 is 28. You do nothing with the plus. You keep going right. You do 7 times 3, which is 21. So I've done all the multiplying and dividing from left to right. Now I start over, add, subtract. There's only one thing left to do. 28 plus 21 is 49. So let's go back to our example at the top. Using order of operations, you know that you multiply before you add. So 9 times 5 is 45, plus 4 is 49. That is the correct answer. Benny added these first. He went 5 plus 4 is 9. And then he went back and multiplied by 9. 9 times 9 is 81. That's how Benny got that number, was by going out of order. So yeah, there really is only one right answer to that. All right, let's do another one. Number 2. 2 times 6 minus 4 divided by 3. All right, we start with grouping symbols. There aren't any. Exponents. Nope. Multiply, divide. Yes, we're going to go left to right. So this is the first one we hit. 2 times 6 is 12. Just recopy the rest. We're going to head to the right. We don't do anything with subtraction. And then the next one is 4 divided by 3. So I have a 12 minus, and I can just stack this up, 4 divided by 3. And I've done, and that it doesn't divide out. So that's as far as I get with multiply, divide. We start at the beginning, add, subtract. Well, there's only one thing left to do. So we're going to put these together. I need a common denominator. So the 12 gets multiplied by 3 over 3, which makes it 36 over 3 minus 4 over 3. So 36 thirds minus 4 thirds is 32 thirds. All right, we're going to do one last one before we move on. This is number 3. 6 plus 12 over 5 times 3 minus 13. Okay, a fraction bar is a grouping symbol. And following the rules for grouping symbol, you do inside to out. So what does that mean? It means first you do the top, so inside the top. Second, you do the bottom, inside the bottom. And then last, which is your third step, you reduce it if you need to. So we do the top, we do the bottom, and then we do them both. All right, so looking at the top, there's only one thing to do. 6 plus 12 is 18. Top is done. Now the bottom. Exponents, no. Multiply, yes. 5 times 3 is 15. We're done on the bottom with the multiply, divide step. And then last is add, subtract. 15 minus 13 is 2. And we're done with the bottom. Now the third, this is where we reduce. 18 divided by 2 is 9. So all the top, all the bottom, put them together. All right, Roman numeral 3. Properties. There's actually a lot of properties we learn in algebra, so we learn them a little bit at a time. Properties are the rules we follow because they work no matter what the numbers are that we're using. Properties are always true. And some of these you're going to be like, well, that's obvious. But the things that you think are obvious, 3,000 years ago, mostly in Greece, they had to argue about. You had to prove it. And so if you imagine in Greece, you have a lot of, you have a pyramid structure. So you have a few really wealthy, mostly men. And then you worked your way down to the trade class and the soldier class, and then, of course, servants. So the people at the top of the pyramid basically had no job. So what did they do? They liked to invent stuff, and they would take it to assembly and argue about it. Most things at assembly had to be argued about for a full calendar year. If nobody could poke holes in the argument, then it was canonized, which means it was made permanent. And that's why so many of our algebra things are named after Greek guys, because of course they want to name it after themselves, So Pythagorean theorem was Pythagoras. Cartesian graphing was Descartes. That was much later, of course. But point being, a lot of our stuff is from people that invented it and had to argue about it. Here's the first one. Substitution property. Substitution property says if A equals 3 and D is equal to A, then we can replace A with 3. We get D equals 3. So it says if something is equal to a number, then you can replace it with that number. That's substitution property. All right, number 2, this is reflexive property. And I want you to write 3 down because these are oftentimes mixed up, reflexive and symmetric. Reflexive is like your reflection in a mirror. When you look in the mirror and you see yourself, you look exactly the same as you do in real life. Reflexive property says A always equals A. Something always equals itself, just like your reflection. Now, symmetric property, slightly different, but very close. If A equals B, then you can flip it around, B equals A. So remember, symmetric means it's the same on both sides. That's what this is. It means you can flip it either way across the equal sign.
Can I use the bathroom?
Okay, number 4. Transitive. This is one of the hardest ones to recognize. Transitive property. Transitive property has 3 pieces to it. And transitive says if A equals B and B equals C, then A equals C. The first one and the last one must be equal to each other. That is transitive property. We'll answer questions at the end. So write your questions down if you have them. We'll answer them at the end. Transitive property you can recognize because it always has 3 pieces, A, B, and C. Okay, identities get the name because no matter what you do to the number, it stays the same. It keeps its identity. So number 5 is additive identity. And I bet you could probably guess this one. What can you add to a number so it stays the same? A 0. A plus 0 equals A. It keeps its identity. That's additive identity. We added something to it. It didn't change. Multiplicative identity. Again, it's what you multiply something by, so it doesn't change. Well, that would be a 1. B multiplied by 1 is still a B. That's your multiplication identity. Last property I'm going to throw at you today is the multiplication property of 0. And again, you already know this. You probably just didn't know that it had a property attached to it. It says anytime you multiply a number times 0, it's 0. So A times 0, whatever A is, it's always going to be a 0 when you multiply by 0. Now on your homework, there's a section where you will look at it and name the property that it's showing. I think you'll be pretty good at that one, especially if you have your notes out. The other one is you'll actually go step by step through order of operations and name the property. That's the one we're going to practice, and then we're done with notes today. So 5 bracket 3 minus, in parentheses, 6 by 2, 6 divided by 2, parentheses, bracket, plus 4, and it will just say simplify. And their directions will say simplify and write the property next to each step. Now there's lots of other properties. We're just learning these 7 today. Okay, so order of operations says grouping symbols first, inside pair first. So brackets are grouping symbols, but inside that we have parentheses. So we're going to start there. 6 divided by 2 is 3. So now I have a 5 bracket 3 minus 3 bracket plus 4. So I basically substituted a 3 in 4, 6 divided by 2. So that would be substitution property. There are arguments for other properties that you could use, but we're just going to use the ones off our abbreviated list. All right, still in the grouping symbols. 3 minus 3 is 0. So now I have 5 bracket 0 plus 4. Again, we just subtracted and replaced it with 0. That's substitution property. There are no exponents. So we go on to multiply, divide. That goes next. 5 times 0 is 0. That one is your multiplication property of 0, because anything you multiply by 0 is 0. So that one has a specific property. And then last is add, subtract. 0 plus 4 is 4. So the 4 didn't change. That would be additive identity. Remember, the word identity means the number didn't change. Add says you added something to it and it didn't change. All right, are there any questions about this?